Let's take a look at some sample problems from section 7.7 on quadratic equations and their applications. In the first three problems, we're asked to solve the equation by using the zero factor property, which means if we're multiplying two factors to get 0, then one of the two factors must be equal to 0. So to make this first factor be 0, x would have to be a -6, and to make the second factor 0, we would get a -4. So those are our two solutions. In number 10, we're still doing the same thing, but this time we have to factor. It's not factored for us. So the leading coefficient is a 1, so we can put in x and x. We need to multiply to get -5 and add to get 4. So that would be a +5 and a -1. And so our two solutions to make the first factor be 0 would be -5, and the second factor to be 0 would be a +1. Okay, in number 14, we're doing the same thing again. First of all, though, we notice we don't have a 0, so we can't use the zero factor property until we get it equal to 0. So that's what I'm going to do first, is subtract 2 from both sides so we get a 0 on the right. Now we need to factor, and this is one of those that I have to take 15 times -2 would be -30, and I want to come up with two numbers that will multiply to give me -30, multiply to give me -30, but add to give me a 7. And so 30 times -1, 15 times -2, that's not going to work. 10 times -3. Okay, that's the one that'll work. So I'm going to rewrite 15x squared plus 10x minus 3x minus 2 equals 0. And then I'm going to factor these in pairs. So I can take out 5x, so that's 3x plus 2. And I can factor out a -1, and that'll give me 3x plus 2. Now we have 3x plus 2 in common, and that leaves 5x minus 1. So to get 3x plus 2 to be equal to 0, we need to subtract 2 and divide by 3. That gives us -2/3. And to get 5x minus 1 equal to 0, we need to add 1, divide by 5, and that gives us 1/5. So we're getting x equals -2/3 or +1/5. Okay, starting with 18, we're to use the square root property, and we're only to give real number solutions. So we take the square root of both sides, and when we do that, we insert the plus or minus over on the right. The square root of 16 is 4, so we get plus or minus 4. In number 28, we're going to do exactly the same thing. Take the square root of both sides, and on the right we insert plus or minus. Now we're going to subtract the 1. Notice we can't simplify the square root of 19, and then we're going to divide by 4. So here are our two solutions, -1 plus the square root of 19 over 4, and -1 minus the square root of 19 over 4. Now we move on to the quadratic formula. So let's rewrite it up here, and we use the coefficients. X will be the opposite of b plus or minus the square root of b squared minus 4ac, whole thing over 2 times a. So as we look here, a is 1, b is 2, c is -5. So we have x equals -2 plus or minus the square root of 2 squared would be 4, minus 4 times 1 times -5, all over 2 times 1 would be a 2. And here we're going to get a positive 24. And 24 we can break down to 4 times 6, so the square root of 4 is 2. And so we get -1 plus or minus square root of 6. Notice we have to divide both terms here by the 2. So those are our two solutions. Alright, and 36. Okay, again, we have to have it equal to 0, so the first thing we need to do is multiply this out and move the 19 over to the left. Okay, and now we're going to have to substitute, and I think I'm going to have to move to the next page. So A is 4, B is -4, and C is -19. So x would be the opposite of b, that would be positive 4 plus or minus the square root of b squared. -4 squared is 16, minus 4 times a times c, all over 2 times 4 would be 8. So let's see, we have 16 minus 4 times 4 times -19. And that's 320 all over 8. Okay, let's see. I know we can take a 16 out of there. Okay, let's see. 16 times 20. And so that's going to be a 4. And then I'm going to be able to break this times 4. Square root of 16. Okay, and this is going to be able to 4 times 5. So I can bring out a 4 and a 2, and I have a 5 left inside, so I can take out an 8. So it's 64 times 5, I believe, gives us 320, yes. So plus or minus 8 square root of 5 divided by 8. Now I can reduce this sum. I can reduce it by a 4. So we get 1. We get 1 plus or minus 2 times the square root of 5 over 2. Okay. Now let's do some application problems. And we'll do one here, and then I'll have to break and do the others in another recording. It says a high-rise condominium building is 407 feet high. Suppose that a ball is projected upward from the top, and its position in feet above the ground is given by the equation S equals -16t squared plus 75t plus 407, where t is the number of seconds that have elapsed. How long will it take for the ball to reach a height of 450 feet above the ground? Okay, plus 45t plus 75. Get the right one here. Plus 75t plus 407. So there's our equation, and we're to find t, and how long will it take for the ball to reach a height of 450 feet? So 450 is the number of feet above the ground. So we're solving for t. So the first thing I want to do is subtract the 450 from both sides. Oops, 450. And so I get 0. So we're doing the same thing we did with the other problems. And let's see, it's going to be negative 43, I believe. Okay. Now what I'm going to do is, at this point, we have a couple of options. I guess I'll go, it looks like it might be kind of messy to factor. So t, since we're working with t here, equals the opposite of b plus or minus the square root of b squared. 75 squared is 5625 minus 4 times a times c all over 2a, 2 times negative 16. So let's see what this mess is. Minus 4 times negative 16 times negative 16. Wait a minute, that should be a negative 43, not a negative 16. Minus 4 times a times c. Correct that. Okay, so we have the square root of 2873. And the square root of 2873 is about 53.6. Okay, so if I take negative 75 plus 53.6 and get negative 21.4 over negative 32, I get positive 0.6687, so that's about 0.7 seconds. And then if I do it with the minus 75 minus 53.6 equals, divided by negative 32, I get my two answers. Okay, so the numbers were a little bit big and messy there. Okay, I'm going to stop here and pick up in the next recording.